Okay, this is question number 9 from section 3.2. Somebody sent it in to me. And we've got this empirical rule, which is really like a quick, way to estimate percentages of any normally distributed phenomena. Like we know that the phenomena is normally distributed based on the number of standard deviations we're talking about from the center. We can quickly kind of estimate what percentage it is. Now, of course, later we're going to have calculators that can give us a real accuracy out to any number of places, and will be really nice. But it always is a good idea to have just an idea of what we're talking about. Okay, so here our normal distribution is IQ test scores, and we know that the mean of the distribution is 100 and the standard deviation is 13. So we're going to be asked to calculate what percentage of people have IQ scores between 74 and 126, for example. That's the first one. So the first thing is just to go over the empirical rule real quick. Here's my general drawing. My video is in the way a little bit. Here's my general drawing of a bell-shaped curve, okay? The middle, the mu, right, is the mean. That's just a fancy symbol for the mean. That's always in the center of the bell curve. And then you have, if we add one standard deviation, we go this way. If we subtract one standard deviation, we go this way. Okay? And then if we go 2 standard deviations to the right, we go all the way over here. And then 2 standard deviations to the left, we're here. And then 3. So these are kind of our points of reference for using the empirical rule. And we know that, I think that my picture might have erased this, but right here, between 1 standard deviation to either side of the mean, right, you're going to get 68% of the distribution. Between 2 standard deviations, you get 95. So 95 of the people are going to fall between 2 standard deviations either way. And then 99.7 between 3 standard deviations, okay? So now that, if you remember from the question, our mean for our particular normal curve is going to be 100, and our standard deviation is 13. So I drew out the particular situation in this case, right? Where 100 is our mean. I add 13 to go up 1 standard deviation, add another 13 to go another standard deviation, and another 13 to go a 3rd standard deviation. I did the same going in the negative direction here. Okay, so we know that 68% should be between 87 and 113. We know that 95 should be between 74 and 126. We know 99.7 should be between 61 and 139. So let's go back to the questions. What percentage are between 74 and 126? Right, that's 2 standard deviations, 74 to 126 here. So that's 95%. Okay, and that's just straight empirical rule. Okay, then we have between 61 and 139. This is going to be, right, 3 standard deviations. Okay, so we know from the empirical rule, right, that 99.7% are between 3 standard deviations. To either side of the mean. Oh, I wasn't reading very carefully, right? What percentage of the people has IQ scores less than 61 or greater than 139? So yeah, I guess it pays to read these carefully. So I was looking at what's between, right, these two, and they want to know what's less than or what's over here, and then what's over here. Well, the whole distribution is 100%, right? 100% of the area. So we're going to really take 100% and subtract 99.7 from that. So 100 minus 99.7. 0.7 is just going to give us 0.3%, right? All right, let me see if I can get this right on the second try. 0.3%. Okay. Now, last one's a little trickier. What percentage of people has an IQ score greater than 139? So if I look back at my normal curve, we're talking about people just on this side, right? Now, the last question talked about people on this side and on this side past the 3 standard deviations. So given the symmetry of the normal curve, this just has to be half, right? If there's 0.3% of people on both sides, right, then half of that has to be just on one side. So we're just going to take half of our last answer. Okay. So what was that, 0.15%? So I hope that helps a little bit using the empirical rule.